So now it's my great pleasure to introduce our first speaker today. Dr. Dava Newman is the Apollo Program Professor of Astronomics at the Massachusetts Institute of Technology. She also served as Deputy Administrator of NASA from 2015 to 2017, and in that role, she was responsible for providing overall leadership, planning, and policy direction for NASA. Today, her research focuses on aerospace, biomedical engineering, and investigating the effects of gravity on humans in different environments. That actually sounds like fun. We'll have to test her out on that. So with that, put your hands together and please welcome Dr. Newman to the stage.
Hello, everyone. I'd love to talk to you about humanity becoming interplanetary and also making positive change for Spaceship Earth, my favorite planet. Exploration has three fundamental questions. Are we alone in the universe? Are there other habitable planets? And is there life? When are we going to find it? The evidence is mounting. I think in the next decade, we might find past life or current life throughout the solar system. You're watching these fireworks, these cosmic interstellar fireworks. This is from our magnificent Hubble Space Telescope. To search for these questions, are we alone? Are there other habitable planets? And what about life? You've just seen stellar formation of 3,000 stars. So what guides my work and the research is thinking about all of our exploration and what it means for us down here on Earth. You're seeing an image of Earth from our Discover mission. It's like a space weather buoy. It's at the Lagrangian point, Earth and the sun. And then 1.5 million miles out there, there's a space weather buoy saying, hey, Earth, guess what's coming? All this space radiation, space weather. How about Mars? That's my passion. We will become interplanetary. We'll send people to the moon next and onward to Mars. Mars, at half the size of Earth. It seems very dry and cold, but guess what? We just discovered organics. Guess what? We have seasonal water on Mars. We know there's ice on the North and South Pole. So those are the building blocks of life. I think 3.5 billion years ago, it's likely that Mars had life. Earth and Mars, sister planets. Life worked out pretty well for us here on Earth. What went so terribly wrong on Mars? It lost its global magnetic field. And its atmosphere today is only 1% carbon dioxide. So the story continues. Tell you a little bit about the research, first for Mars, and then bringing that home to Earth. We've been to the moon. These are my Apollo bloopers.
Jack Schmidt having a few problems.
So as an aerospace engineer, rocket scientist, I'm thinking, how do we enable astronaut performance on the moon, 1/6 gravity? Essentially, the design is taking a spacecraft and shrinking it down to the human. It's an amazing engineering challenge. I call it the world's smallest spacecraft. But you can see it's pretty massive. It's not very mobile. It definitely wasn't enhancing the science that we could do on the lunar surface. In the middle, that's our current system. At 140 kilos, our design goal is to throw technology, innovation, what can we do to reverse that paradigm? Rather than literally the man in the can, how can we make a suit that is based on your performance, your design, a custom suit? It's literally called a second skin. Let me show you where I think the future is going, to enable exploration. Why? Because we're not going to stand around on the moon, and when we get to Mars, we're going there to search for life, past evidence, or current life as it exists today. So this is our design. We call it the biosuit. It's an order of magnitude less in mass, and it's very flexible. You get your own suit, you get a custom suit, everyone gets one, so we won't have that problem with not being enough suits, especially for women. How do we design it? Well, we map you in motion. So the design philosophy is to literally look at your motion, your movement. These are stress-strain fields on the elbow. And if I map you, put little infinitesimal circles all over, I want to empower you, because Mars is 3 times the highest mountain on Mars is called Olympus Mons, and it's 3 times Mount Everest. The largest canyon is Valles Marineris, and that would stretch across the entire United States. So now who wants to go on my 4-year Mars mission? Come on. All my students still want to go to Mars, but it's a tough challenge. Why do we do it? Because it is the hard thing to do, because it's challenging. That's why we explore fundamentally, push ourselves, as an engineer, push ourselves to the limits. Now let's bring it down to Earth. All of our exploring, I submit, is for one reason, and that's to learn about life here on Earth and to be in balance with the Earth. So I think Bucky Fuller said it the best. To make the world work for 100% of humanity in the shortest possible time through spontaneous cooperation without any ecological offense or any disadvantage of anyone or to any living being. What you're seeing then is from NASA and our European Space Agency, the eyes on Earth, all of our satellite data hosted on AWS, much of it, and the supercomputer simulations, so we can look at the oceans changing, the currents changing. We can see literally through the clouds, agricultural, soil moisture and mapping, the temperature in the seas, the currents, all of this holistic look at Earth and all of our systems. Our systems are oceans, land, air, and then from near space, eyes on Earth. So if we look at Earth, I'd like to show you the vital signs, because to me, Earth is a living, breathing, enormous being that we really need. We, humanity, we need Earth. Earth doesn't need us. Here's global temperature taken since 1880. Blue and white are 1 to 2 degrees Celsius below a running average mean of 30 years. Yellow and orange are 1 to 2 degrees Celsius above an average. You can take a look at the decades. If you want audience participation, raise your hands. We're going into the 50s here. Going to go into the 60s. All right, 70s. Thank you for participating. Here comes the students, 2000 to 2010. It's hot. 2016 was the hottest year ever recorded. It was an El Nino year. 2017 was second. Matter of fact, I can show you data for each month now. We're setting records. We're surpassing records. We all know the studies. 2 degrees does change our world. We're at 1 degree now. So, the vital signs. I'd like to show you global carbon. We don't want to be above 410 parts per million. Yellow and orange are going to be above that threshold, into the 400s. Blue is into the 300 parts per million. This is just 1 year in the global carbon dioxide cycle. It's from 2014 to 2015. I want to show it to you in 3 dimensions. You're literally looking down through the atmosphere. 5, 10, 15, 20 kilometers up. This is human cause. This is us. Sure, and some natural disasters, the forest fires. But these are our emissions. But we can do something about it. I remain eternally optimistic through spontaneous cooperation for all of us working on this together. The Earth's vital signs. The Earth is breathing, the Earth is speaking, but are we listening? My last Earth vital sign is going to be the glaciers. I had the distinct privilege, as you heard, to serve at NASA, get to South Pole. I'm a scientist, I'm an engineer, I can't get enough data. How are our glaciers doing? Greenland and Antarctica, they hold 99% of the world's fresh water trapped in our ice sheets. They're melting quickly. Take a look at this simulation. Take a look at the latest campaign, flying campaign, looking at the atmosphere, ground penetrating radar. We look at the land, we look at the oceans. You can see the velocity vectors of the ice melting, the Greenland ice sheet. There's the numbers, just under 300 gigatons in 1 year. Antarctica, the same year, lost 125. So we're at 400 gigatons of ice lost in 1 year. Well, what does that mean? Well, that's 3 times the size of Texas. This is causing the ocean to rise. If the Greenland ice sheet goes, that's 6 meters of sea level rise. Since 1990, we're here, we're 2025, but it's on an exponential curve. So, Earth's vital signs. We need to listen. Earth is speaking to us. What can we do about it? We have a lot to do about it. So, at Earth DNA, that's our nonprofit, taking all of the NASA data, the satellite data, the atmospheric data. There's so much data on opendata.gov. What can we do with it? It's overwhelming even to the scientists. We can curate it. We're using a lot of artificial intelligence, most recently GAN, some generated adversarial networks, to curate that data so it makes sense. Because you know what? I can show you global data, the vital signs of Earth, but what you care about is maybe your state, regionally, local. And guess what? You really care about personally, you and your family. So we want to put it literally in the palm of your hand. Those terabytes, gigabytes daily of data. So you curate your own dashboard. What does it mean to you? Well, as an explorer myself, I really care about the oceans. I think we can really accelerate change, positive change, if we look at the oceans for all of climate. Let's look at the oceans. These are our biggest challenges. The ocean warming, sea level rise, I mentioned, the acidification of our oceans, overfishing, and pollutions, and the micro-pollutions. So then my story, what does that mean to me? Well, I'm a sailor. We circumnavigated, sailed our boat around the world and survived, so I'm here talking to you. But what did we find? All those stories, those island nations. People understand sea level rise. They understand living in balance with the Earth. So if you look at the oceans, then we can put it in the palm of your hand. What can you do? We can change. As a scuba diver, if you're scuba divers and love the underwater world to explore just like I do, you know, in 1 year, last year, we just lost 30% of the Great Barrier Reef in Australia. That's the effect of temperature. That's the effect of these vital signs of Earth. So they're right in front of us, but I can give you all the data in the world, and I still say that's the easy part, curating the data, giving you this platform, letting you make sure that you have your own dashboard, so you type in your zip code, because it matters to you and your family. What else can you do about it? Well, I can change my carbon footprint. Surely I can. What do we eat? What do we all eat today? What mass transit do you take? So I don't have the solutions for you, but I know what my solutions are. So now I wake up each and every day and say, what's the most important thing I can be working on? And my answer is this: having the discussion, sharing the news, the vital signs of the Earth, and empowering everyone to take an action, can be a small action every day, so that we get this done within the next decade. I might have 2 decades to become interplanetary, get my students to Mars, but I really think it's so critically important that we have this decade to really accelerate change and live in balance with Spaceship Earth. We have an advantage from space, looking down. Earthrise, you're going to hear next, and it's the overview effect. All astronauts are transformed when they look back down on our beautiful blue planet. So we want to make sure all the girls and boys out there can have the same experience. Thank you very much for your attention.
So our next speaker also served as Deputy Administrator of NASA from 2009 to 2013. Today, Lori Garver is the CEO of Earthrise Alliance, an initiative to fully utilize Earth science data to combat climate change. From 1996 to 2001, Lori worked at NASA first as a senior policy analyst and then as an associate administrator for the Office of Policy and Planning. And I was just talking to her backstage, and she's clearly an innovator. So please put your hands together and please welcome the Honorable Lori Garver to the stage.
Good afternoon, my goodness. Air and Space Day. What do you do on the other days? This is clearly the best day, encompasses everything. And to me, the importance of viewing the Earth from space is what has really allowed for us to understand more than we have ever known about our planet and life on it. So this is Earthrise, the very first picture taken of the Earth from the moon, looking at ourselves for the first time in the mirror. We have many things that are attributed to this photo, like the environmental movement. It is generally known as the most influential photograph ever taken. So in my view, this is something that NASA has given humanity, and it is time that we continue to increase our ability to understand the planet Earth from space. We live in a time when we understand that our planet is changing. The Earth's going to be just fine. As Dava just said, it's humanity on the Earth that is at risk. We know, the science has told us, most of this information from NASA, that we humans are influencing the future of the planet and not in a good way. Global warming, the contaminants in the atmosphere, heating the planet, causing Antarctica and Greenland melting, which is going to cause sea rise. NASA studies this, and in my view, it's time for us to let them do more about what it is we can do, applying that knowledge to civilization. We know, David just outlined the models of the drought and the heat that's coming. We have the tools to understand this now, and the organization that I founded recently called Earthrise is utilizing the unique vantage point, the perspective overview effect of the Earth from space to localize that data and show people what's happening in their neighborhoods so they will do something about it. We know that in all of our generations, each generation has had a better living situation than the past. We are the first generation where that is not going to happen. I have a couple of kids. Whether you have kids or not, I'm sure you don't want to leave the planet worse off than we have it, and that is what we're doing. So in attempting to turn this around, we need to understand what it is that will motivate people to treat each other and the planet differently. And we know a lot of that is localizing data. So what Earthrise does is take images like this of Earth. This is the Amazon. Where do you start for most climate change talks, but in the Amazon? The yellow areas are the protected indigenous Amazonian rainforests. Over this 30-year period of time, this data shows what has happened to the rest of the Amazonian rainforest that is not protected. Moving to Cape Town, South Africa. You probably heard about the dam that supplies 41% of the water to the city of 4 million, and it got below, with that center photo last April, 12% of its capacity in the reservoir. If you get below 10%, you can't utilize the water in the dam. Due to some of this information and conservation and the weather getting allowing us to fill the dam, we got through that immediate crisis, but they were counting to a day zero with no water. We also look beyond the impacts of climate to humanitarian crises. These are the Muslim internment camps in China. China is denying that they have these camps, but we can tell from space data that there are more than 1 million Muslims who have been interned in these encampments. We can also look, however, at things that are being done to help the planet. This is closer to home, right under the Golden Gate Bridge. You see the ocean cleanup, which is a ship heading out to clean up the big spill that's in the ocean, or the Great Ocean Patch, as it's known. These are things that if people knew what we could do and see from space, they would treat our planet better. My last example is of the Maldives. This is a part of the world where the United Nations was keeping healthy mangroves and had mandated at least a 70% retention of the mangroves. But 2 years later, satellites show that, in fact, only 30% of the natural mangroves are left. So it's not a great story. But I am here to tell you that we are living in a very exciting time, because we're here at a time we can do something about it. There has been, we are in, a renaissance that has allowed us the capability to know more about the planet than ever before. Much of this is because of NASA investment, but some of it is also because of you. We start by access to space. Through policies we helped drive in the Obama administration, Dave and myself, we are able to reduce the cost of getting these satellites to orbit. Satellites are more capable than they've ever been, and their size is greatly reduced. In addition, however, your data science has enabled us to understand this information. It doesn't really make a lot of sense to get the data out there if you can't access it and be able to utilize the tools that you have developed in order to make decisions that will impact the planet in positive ways. So we founded Earthrise Alliance to be able to connect this information to communities who can use the information effectively. Those for us are journalists, educators, and civic organizations. Now, why these groups? They are large groups, and they use local data. So we have a newswire, where out of the hundreds of thousands of stories a day, we identify those stories off the newswire that can benefit from images of the planet in those local areas to be able to tell a story. That series of images of the gulags in China, the Uyghur camp, were told by Reuters through Earthrise, connecting them with that data. We take the images that are available, not just from the government, from the private sector. We have agreements with Digital Globe, Planet, Airbus, all who have this information and sell it normally, but allow us to use it for humanitarian purposes for little or no cost. We then, just like anybody in data science, look for patterns to be able to identify where it's going to be the most meaningful and develop applications to communicate what's happening. So an application I'll mention, and Dava's so interesting, she has a very similar one to talk about your own climate footprint. But for us, we're talking about training data that will utilize teachers in junior high and high schools who can give an assignment to a class. This assignment, for instance, is look at the mangrove destruction in China. They will make available the data, but students will go and look for the examples that they can find, real science data. So they'll be learning how to look at the data as well as be able to then share the story through their own social media apps, whether that's on Instagram or others. A lot of times the value proposition of space has been a given. We go not because it's easy, because it's hard. We go because no one's been before. I think it's time, personally, for us to really look at the value proposition of space. NASA did an amazing thing with Apollo. We were given a mandate, a policy mandate, to go to the moon within 10 years, and they did it. I feel that the mandate is now to take those 10 years, let NASA lead, and be able to understand and translate what's happening about the Earth to save it. Right now, we have put in 600 people into space. NASA, about 400 of those. NASA spent $1.1 trillion in the space program in the last 60 years. So not all of that is on human spaceflight, so I'll give them a break there. That probably around $400 billion was spent on human spaceflight for 400 people, so $1 billion a person. That's your value proposition for the human spaceflight program. NASA also gives advances in aeronautics, in astrophysics. They study the other planets. We've actually spent nearly as much studying the climate of Mars as we have the climate of Earth. So for me, the value proposition is the population of Earth. It's 7.5 billion. We have the knowledge, the capability. We live in a time, thanks to much of what has gone before, to do something about it. So I am optimistic that we can turn this around, but it will take all of us to do that. One of the things about Apollo is it inspired people, a generation. It was primarily white males. I'm going to talk about who might be inspired by a mission to save the Earth. I started a fellowship program called the Brooke Owens Fellowship 3 years ago in honor of a dear colleague and friend who died at the age of 35 of cancer. We have had 3 classes of full-time paid interns and mentorship for these 3 classes over the last 3 years. These women are aerospace engineering majors, primarily, and of course they're inspired by everything we're doing in space. But we study why it is that women have not been more involved in engineering and in the space program specifically, and we know it's because they have not connected it to the value that we get from space. So to me, we need these women, we need everyone on the planet to recognize the value that we have brought and how we can translate that now into the real benefit for planet Earth. So we do at this point spend about 8% of NASA's budget on Earth sciences. And my proposal would be that we change the balance. We've just laid out the fact that there's a program that this administration wants to go back to Mars and to the moon in 5 years. And we're building spacecraft, and we'll spend tens of billions of dollars doing that. In my view, we should refocus on the planet, the one planet in the universe that we know can sustain life, good old Earth. And I know that for my 35-year career in space, no one should feel that NASA didn't contribute in so many ways to our civilization and to the world. It's time now for us to turn back and look at how we can use that knowledge for Earth. So thank you very much. I look forward to the discussion.
Well, I'm so excited, delighted, and amazed to both have you here and just see what you're both doing. It's really exciting to have 2 amazing women scientists working in this area, and the fact that you're both here with us today. So let's give them one more big round of applause, please. So I have a few questions for them that we're going to talk about. And I'd like you both to answer this question. The pace of innovation across Earth, science, and space is incredibly fast. You've both seen a lot of change since you started your careers. What are the most impactful breakthroughs that you've seen over the years? Let's start with you, Lauren.
Okay, there's a lot, but just recently, heavy lift launch, that's going to be huge. That's how we get humanity out into deep space, back to the moon and Mars. It's coming. And then in terms of our awareness and just the democratization of space, that's what we call it. All this satellite data we shared with you and empowering each individual. Because it's data for everyone. It really is global coverage all the time, almost real time. So those are a couple.
Yeah.
I can get into space suits or life support, other things like that. I'll let.
Yeah, but the access to data, I think, is one of the things we were talking about backstage. Lori, what do you think?
Yeah, I mean, I discussed it. I called Earthrise with capital R-I-S-E, that was to signal a renaissance in sensing the environment. To me, that is the combination of innovative ways to not only gather the data, but to store it and have access to it. And you could not have any of this, these key findings and all the information that Dava shared without the ability to access access that. We recognize that government employees aren't the only ones with all the great ideas.
Yeah.
And so I think they've really done an excellent job of tapping a broader community to innovate in ways. I mean, that's the whole point, really, is to have the government invest in things that can be used beyond to help people.
In that public-private partnership, you're right, the ability to actually do things better, faster together. And that's why I tell everybody I love working with public sector, because we get to do the government side, the education side, and the not-for-profit, which can really come together and do things and then even make good recommendations both on the not-for-profit or the educational side back to the government. Even, startups, you don't have to be a not-for-profit, but it's just those great recommendations through learnings. So Lori, I'm going to come back to you on this question. How has the exponential growth of available data helped Earthrise Alliance fulfill your mission to combat climate change?
Well, so we wouldn't have even been founded without it, because our whole mission is to take data and make it more accessible to people who make decisions ultimately about our resources, to manage them better.
Yeah.
And obviously the data exists, so the real question is, how do you change behaviors? And our very smart people who do this, who are former NASA employees, data scientists, found and developed an algorithm that takes the available data and is able to source from private sector as well as government, and put it into a format, both apps and web-based, that allow you to see local change. The old phrase about acting locally, think globally, act locally, is so
Yeah.
true. People care about what's happening in their backyard. And so it's very hard to source that information yourself. So the ability of our folks to take the data and put it into a format that is usable would not be possible without all the tools that currently exist.
It's so much fun, though, to see that individual. When I go around to small colleges or high schools, I hear students talk about that they're doing research because they have access to data now that's out there, and then that compute and processing that they need. So that we're hopefully creating those young educators, researchers who are learning more on their own just from the open data that's out there and the accessibility of it. So, Dava, let me ask you, Dave, let me ask you, you've spent a lot of time studying Mars, which I love. For those in the audience wondering about life in or outside our solar system, what technologies or discoveries on the horizon do you hope will eventually answer those questions?
Okay, so I love that question. But did I tell you Mars is my second planet after Earth's number one? But I have spent a lifetime. And so since we're searching for life, when we get there, maybe you saw The Martian too as well. We can talk to you about technologies for Mars there. It won't be all potatoes, but technologies we don't have today that we need: advanced life support systems and suits. And again, I mentioned the heavy lift launch. That's how we really do deep space exploration. So we'll get there, but we have 2 decades, I think, to get people to Mars. We were chatting before, other technologies and just other information that maybe everyone doesn't think about every day. I breathe and sleep and think about Mars every day. If you don't, we're looking for Earth-like planets as well. So they're called exoplanets. We have 6,000 of them. So a second Earth, surely, yes, it's out there. Surely, yes, there is life. It might be fossilized. But of the 6,000 exoplanets, we can't get to them anytime real soon because they're 10, 20, 100 light years out. But we're studying them. Why? Because we care about life here on Earth, and they have the building blocks of life. Closer in the solar system, we have something called ocean worlds.
Love this.
It's worked out pretty well for us here on Earth. Our oceans, I submit, hold the keys to climate because that's really the food source. That's the biodiversity, the oceans. All the systems are connected on Earth, generating the oceans, the atmosphere, the rain, everything else. So we're all interconnected. So we look around the solar system and we call those ocean world missions, because when you're looking for life, we say follow the water. And so Enceladus is a moon of Saturn. It should go to Europa, that's a moon of Jupiter. These are all ocean worlds, and they have the best probability of finding life
I can't imagine what we haven't discovered yet. It is amazing, right, when you think about there's so many new discoveries. And we always say, oh, I'll hear people say, oh, we've discovered everything. Hardly, right? When I hear you all talk, you know that we are really just scratching the surface on discoveries. So a lot to be done. So this is for both of you. So maybe Lori, we'll start with you on it. You're both advocates, which I thank you for this, by the way, for building up the next generation of explorers, scientists, and leaders across space. What do you hear when you speak to those young students? And I love your perspective on young girls as well. How can we better encourage people of all backgrounds to explore the careers in STEM?
Well, I mean, this is a passion that we share, and of course NASA is a beacon for people who are interested in doing amazing things with science and technology. So we have them at Hello, and to me that is then we make the pivot to talking about the kinds of things that they can solve by studying what we're doing in science and math and engineering and the arts. I'm a big believer. I don't have a science degree. So to me, we do need to recruit everyone. And the challenge today, especially around climate, is not just the science. It almost is more of a communications challenge and a political challenge. I think we all have some idea. As a policy person, I know what I would do policy-wise if we had people understanding the challenge that's in front of us. We certainly have science and technology solutions. So I think it really helps to recruit people around a cause. And NASA had that 50 years ago. We have been trying to recreate a cause a bit for the last 50 years. We had the space shuttle, we had the space station. It's very inspiring for a certain segment of the population. But I don't think it's everyone, and I think that Earth is.
Yeah, it's so true. I hear from girls a lot purpose when you ask them why they're not taking a computer science class, or when it's usually community, they want that community, and they seem to get a lot more involved when there's a purpose to what they're doing. And so back to your purpose, it's
Look
a
at
really
the
good
biological
point.
sciences.
Yeah.
There's more than 50% of med schools graduating women. They have that connection.
Yeah, so true. It's a really good point.
So it's always about the people. I call it STEAMed.
Yeah,
Very intentionally. I always bring in the artists, the journalists, the storytellers, who tells the stories. And I put a D on the end, because we have a whole new 3D maker generation out there. And I say, you don't want to be a rocket scientist? Breaks my heart, but that's okay. I think we've actually had the wrong conversation.
Yeah.
We made STEM a thing. And I talk to a lot of kids, especially young girls. That's not me. How do you know? You're 5 years old. How do you know you're not STEM?
Yeah.
So I think we have been having the wrong conversation. So now I have a different message. I say, you want to get people to the moon? You want to solve clean water? You want to help us with climate? Well, they're passionate. Everyone's equally passionate about that. They have to see themselves in our roles, and that's not enough. You have to make a really warm, welcoming environment. And we don't have the luxury to waste any resources. I need everyone at the table. So it really is through excellence and diversity. And I say, you know what, those big problems, well, I am an engineer. I love it. I have the world's best job. You don't have to be the best in math, calculus, physics, because how intimidating is that?
Yeah.
I say those are tools. I use physics and math every day, but they're just my tools.
Yeah.
The big picture is, keep your eye on the prize. That's helping with climate. That's helping with exploration. So shame on us. I think we've actually been having the same conversation too long. It's not working. Surely if we empower everyone, we'll do better in STEM.
I love that, because one of the things I've always been an advocate for is if we could teach something that occurred, like if we taught as a subject, how did we get to the moon? And you teach every element, and you don't really see the difference between if it's math or physics or history. So along the way, you're learning, how do you build a bridge? What happened? You can do the history of the bridge, you can do the physics of the bridge, you can do the science of the bridge, the business and finance of that bridge, or a rocket ship. So I agree with you. I think potentially maybe we have explored that too much, and we're pushing in the wrong direction when we should just be thinking about themes that we could teach and really getting all groups energized around that. I love that idea. I think we should explore that together.
Change that,
But of course, the only
conversation.
reason we can is because the data is available. You had to just be one thing
True.
in the past because
so true.
the information wasn't available at your fingertips. So to me, we really do need to look at the way, not just that we're marketing it, but doing it, because interdisciplinary is where you get the real creative innovations.
Yeah, that's such a good point. The data tells you so much. If even I talk about my own org, I'm like, I didn't really know what to look for until I had my data. I could talk about it, but I was talking about things I really didn't know. So, all right, this is our last question, and it's directed to both of you guys. So, well, actually, I'm going to ask for maybe words of wisdom at the very end, but what will the Earth, science, and space field look like in 5 years? Who wants to take that first?
I'll go ahead. I think we'll agree. It's going to look differently. My dream, my hope is, because I hope it's not disciplinary to this point we're talking about. I hope what it is it's cross-cutting, because I need to know about earth science and oceans and land and air, all the subsystems, and space. Because to me, it's actually just a spectrum. So as an aerospace engineering professor, we've taught for a long time. You learn about aeronautics if you like planes, and we teach about, aerospace, astronautics if you like space. No, it's just one continuum. So I think it is incumbent upon all of us to have a different conversation, and then as an educator myself, to really strive. It's really 21st century education. It has to be active, hands-on. What are the big problems we're solving? And then, okay, what are the tools? But those tools surely need to be cross-disciplinary. And it's just more fun. I learn a lot more sitting at the table with someone from a different background than I do with everyone who's trained like I am.
True. Putting a team together that has different thoughts and ideas, right? So, Lori, what do you think?
Yeah, definitely, there's the what will it be and what you hope it'll be, so we'll go with what we'll hope. I think a workforce that is more representative of the population is a huge goal, and I think it could happen, especially if we are able to shift our priorities to a value proposition that benefits more of the population as well. I do believe, we know that astronauts are very, very inspiring, and there is a place for that. It's just the balance. The 8% on Earth is just tough when you got $21 billion that you could spend, I think, more effectively. So hopefully that will happen. For a long time, people have been saying that you will do a job in 10 years that's not been invented yet. There is no question that will even be the case now in 5.
Yeah.
Change. Earthrise would not have been possible 2 years ago.
Yeah.
Literally, the algorithms are being written today based on the most current data. That's what's exciting. And where else to do it but space, and having the space program really recognize that what they bring us are the value of understanding our own home planet.
So I'm going to ask, this wasn't in your list, but I'll kind of ask, because I'd love both your thoughts, because you have both spent time in Washington, D.C. Are there policies that you think we should be thinking about that would help us get there faster? Are there things that we need? Because I always remind my team, anything we do around the world, and I get reminders from my customers where they say, look, we could really use your help with our policymakers in areas. And that's okay, right? You have to educate the policymakers. But do you all have kind of thoughts on things that you think would help us get there with the right kind of policies?
Yes, lots of thoughts on them. So I'll give a few examples. So get back as an educator, led for 10 years a program called Technology and Policy. So it's for engineers and scientists, but specifically to this point, because guess what? Policymakers should be technical people too. Yep. So, we have to do better and get that message out, and training. People need different kind of training. This is different culture. So that's what we can do too, to make sure that people understand that they really do. They can't just stay in the lab and be a scientist. That they're the smartest person there and understand the data. Then I think it's incumbent upon them to help with policy, help inform policy. Yeah. They might not have to come to Washington all the time, but maybe a year fellowship or something like that, a few years, to really get the right policies in shape. And I think, again, we would agree in terms of government institutions and innovation, and some things that you can do there, because we need to accelerate the world, and the data is moving exponentially, but some of our systems aren't moving as fast. I think there's a lot we can do.
Yeah.
I think it's first and foremost about the people saying yes. And as I said, let's just make it the yes, and you don't get to say no, especially middle managers. You don't get to say no. Say yes, but let's have the discussion, because that empowers people. They'll come with their wild, crazy ideas. If you just say, great, Teresa, I want to know your craziest idea to help me. I want to help you solve a problem, or I have a problem. So I gave a word for failure.
Yeah.
I gave a word for failure. It's called fail smart.
Fail
I don't waste
fast,
any
fail
government money,
smart.
but it was fun just to make sure that people, we have to get comfortable with just really, doing your best, taking some risks. Those are a couple of mine.
I love that you're saying that, because we talk a lot about, in Congress, we want to help educate on the new path of technology and why it's important to not just our nation, but even our local communities, and being able, for us, it's about how can we get you there faster with knowledge. And I think the recommendation to have technology leaders on their staff to understanding, I love that idea, and just it kind of helps you move faster into the new world. So, your thoughts, Lori?
Oh, I think there are many policy things that we can do better. I would highlight that there has been some progress made. I think a lot of the policies we worked in at our time in NASA were continued. Public-private partnerships is a big one that has allowed for a lot of these advances that we both talked about, and we can do better. It's difficult for some people within the government to let go and to allow the private sector to step in and do something more innovative when they came to the government to play that role. So policies are needed to give the government that next thing to do that is more innovative and challenging for them, not to have them feel that they're not important. They continue to drive change. So specifically on earth sciences, to me, we spend a lot of money collecting data. And Dr. Jim Hansen, who was the head of the Goddard Space Institute when I started back at NASA in 2008 as the Obama transition team lead at the agency, told me that we collected enough data. What we really needed to do was model the data and spend money on applications. What do you do with the data? And that, I still think, is a huge problem. It's helped a lot to have the private sector step in. And we, in the government, have had to loosen our grip. And while that's hard, they're doing it. I mean, you guys are an example of that for sure. But to me, we don't need to stand back and say, we're only measuring. We aren't going to do anything about it. Something needs to be done about it. And I, for one, trust the people who got us to the moon within a decade. So we need everyone, for sure. But I think NASA has the best brand in the world.
They do.
Deservedly so. And they can keep that current by taking the next hill.
Well, I was really bummed this morning. I got up, and my plan was to wear my NASA T-shirt that I bought just for today, and I could not find it. So I was going to have my NASA T-shirt under here.
Next time.
But I will tell you, all of our engineers, our computer scientists, our leaders, all of us love NASA at AWS. You have no idea. Anytime we talk about anything NASA, they all want to know how they can help. And I think that kind of tells you a lot about really smart engineers and computer science, and everybody that grew up with NASA and still really want NASA to be out there in a big way doing amazing things. Listen, you all are really wonderful. I so appreciate your time. I know everybody in the audience really learned something. So again, thank you guys. Let's give them a big hand. And I look forward to seeing you at the reception, and tomorrow you better get here early. We have like 17,000 people registered. So get here early, and I look forward to seeing you all soon. Thank you again.